Thank you very much for joining us here today. Hopefully you are looking for a very interactive discussion. I know we have experts in the field related to the topic of reclaimed sand under dynamic and cyclic loading. I have prepared a few questions to get the discussion started. I would ask our panelists to comment on them. I'll always start the discussion with one of our panelists, and we'll have a chance for comments from everybody else. So when we are talking about reclaimed island, we are always, or the most common way is the hydraulic reclamation is often what's used in the region here, and it's known for producing highly variable deposits. And what are the most effective methods, based on your experience, to identify this heterogeneity and vulnerability of the soils? I'll ask Dr. Hamid to start commenting on this.
Good morning, everyone. So when we deal with hydraulic reclaimed deposit, it's inherently heterogeneous, as you explained. Now, why it happens? Because of slurry placement, because of segregation of the deposit during transportation, because of different energy level. Now, we always try to minimize this by selection of the proper borrow area, if allows us, if we don't have limitation. We try to control the amount of segregation during the transfer and those things, and we manage the energy, we distribute. But at the end of the day, as you said, we need to now quantify. We need to quantify in the right scale. What is the heterogeneity? To me, the right solution is multi-technique, multi-scale solution. What I mean by this, the standard practice right now, which is actually already good, but we want to make it better, is to perform CPTs every 30-meter grid based on Dubai Building Code, Tarkhis requirement. So the CPT is a good tool, gives us the continuous profile at the given location. It's cheap, we can do it quick, 10, 15 per day we can do. We have correlation for that to develop a lot of, to perform a lot of calculation. Now, what I want to suggest is we combine this with geophysical method to fill the spatial gap between these points on the XY direction. So we can now have our geophysical method like what Mr. Thomas just explained. MSW is a very helpful tool. There are other tools like GPR and ERT, but they're less effective in saline environment that we have in Middle East here, reclaimed material. So mainly these seismic-based methods are very helpful. Now we have seismic-based method, and we have CPT combined with few boreholes to get the fine content from the actual test as well, not only the correlation. And then we need to do geostatistics to find the values and estimate, quantify this variation between these measurement points. So we measure one point, the other point, we have lines even, but with this statistical method, and there have been a lot of development in this field, you can have data on unsampled location. So you quantify the variation, and by now we have all three of these, which is CPT boreholes in one category, your geophysical in the other category, and this geostatistics. You combine all of these, and you come up with a 3D ground model, which quantifies the variation at different locations, and we call it a ground IQ, for example, in Fugro. And with this model, then you can see where are the weak zones, where are a layered pattern, and then you can use this data for your design and risk management. So if I want to conclude, to sum it up for everyone, the first point is we need high density, good quality CPT data, and combined with some few boreholes. We need geophysics to fill the geospatial gaps. We need geostatistics as well, and we need to combine all these professionally to get a 3D ground model.
Thank you very much, Dr. Ham. So any comments from other members who would like to add anything? Or because I would like to keep on time so we can get to all the questions. So any additions you want to add to this point? So with reclamation, it's always associated with some kind of soil improvement. So one of the typical soil improvement, actually some of the questions were related to that, is the densification techniques, which has been proven to be most effective. But mainly when we talk about deep densification, there is always limitation and challenges when we are dealing with deep coastal deposits. Kyle, what's your comment?
Yeah. Assalamu alaikum and good morning to everyone. I'm Khalid Salman, Managing Director from Terra Melius. You know, as we go deeper, they provide a different kind of challenges to the testing authorities and testing regime, all that, because it is because of the excessive overburden pressure, because of the limited accessibility, and because of their unpredictable behavior of the sand and soil below the soil. So it is imperative to find a very a way to do a constructive analysis of that, which we there are actually different method available in the market to do this investigation and compaction purpose, and each of the method has own limitations, advantages, and disadvantages. So we have to find a suitable method for each of the testing regime, and the selection procedure will depend on the soil type, what is soil type, the treatment depth, and the groundwater conditions and the sensitivity of the nearby structures. So there are many methods available like vibrocompaction, like stone columns, like deep dynamic compactions, like deep soil mixing. Each has own merits, own advantages, and own disadvantages. So we can discuss one by one here in this part of the world. Vibrocompaction, deep dynamic compaction, these are more commonly used in stone columns for the deeper depth treatment. Like for vibrocompaction, we can treat up to greater depths, and it produces a vibration, so little vibration compared to the deep dynamic compaction, which has a restraint that you cannot use it close by the nearby buildings, which are restrained. So deep dynamic compaction, you can go maximum 10 to 12 meters, and after that, it is not so economical and not provide a good, reasonable densification compaction result of that. So that's a limited deep dynamic compaction, but vibrocompaction, around the world, we have seen it gone up to 60 meters depth also. Around the world, not in this part of the world, but in the world, I've seen up to 60 meters depth going. But as you go deeper, it will become uneconomical and unrealistic value can come. So in this part of the world, since we have all the reclaimed area in this part, as he mentioned, in Subhasini Island, it started from Palm Jumeirah and all that, that maximum compaction depth using vibrocompaction 14 to 15 meters. The Palm Jumeirah was the first one when it started, and it was maximum 14 meters that we went at that side. So it has all advantages for going vibrocompaction, and dynamic compaction is not good for the built-up area. It can go in the wide open areas, Subhasini Island or that kind of thing. So that's the limitation, and then these two are widely used, and stone column can be used to densify the loose soils and increase the drainage path and compactability, compressibility also.
Thank you very much. Any additional comments?
So from Fugro experience, what we see is dealing with the fine is one of the major problems. Like if we have clean sand, we can, at the end of the day, with dynamic compaction, if it's shallow, or by VC, improve it. When the problem is when we have these zones of silt or higher fine content. Methods like hybrid stone column and VC are recommended, but I think one of the key points is as much as we can, and this is in the hands of companies like Vanord, Gendenol, Buscalis, who are doing the dredging mainly. We can name a few more, but if it's possible for them at the source, control the type of material which comes. That can reduce a lot of effort later on, especially avoiding silt settlement in the ponds, managing the watering properly. These are the stuff that not only focusing on the ground improvement part, but how to reduce the effort for ground improvement.
Actually, that's excellent because that leads me to my next question. In the region here, we deal a lot with, calcareous sands, and again, we get whatever we get from the boring or for the clay soil. So most of the design criteria dealing with liquefaction is basically produced based on silica types of sand. So how much is that applicable to the kind of the regional soils and the clay material we are dealing with? And what is the limitation? So Dr. Khani, if you can comment on that.
Hello. Yeah. So good morning, and thank you very much for inviting me here. Yes, this liquefaction assessment definitely for the calcareous sands is not today's subject. Hopefully, it has been emerged long back. The idea is, as you rightly said, what is the framework that we have to assess this liquefaction is basically based on a lot of histories and a lot of advanced laboratory study for silica sands. The question is whether we can directly apply that framework for the calcareous sands. The answer is no, because the calcareous sands, let us say the carbonate sand, has a distinct geological and mechanical characteristic and behavior. So when I say the calcareous sand, the carbonate sand, again that depends on the degree of carbonate sand that we are talking about. Again, that may vary. If I just share one of my experiences that we had in EDNOC project JADCO, where we have 4 artificial islands, the carbonate content is varying about 50 to 70%. The idea is how this is different from the silica sands. It's not a new thing, but the question is why the existing framework cannot be directly applied, because the calcareous sands has a very distinct features like very much angular, more crushable, and also it has some initial cementation characteristics. So what? Because of that specific characteristics, when that particular soil media or mass subjected under a cyclic loading, initially it offers a better resistance because of more angular and cementation over a repeated cyclic loading that gets crushed. Then, if you ask me to use whatever the CPT data that we get directly from the calcareous sands, it definitely overestimates, because it gives a very higher CPT resistance, which is not actual, especially for the dynamic case. So let me share my experience. So when I said this islands, JADCO islands, we have 4 islands. EDNOC is a client. So since they have hired some consultants, maybe Belgium Fugro, and having said that, they have already done some advanced laboratory testing, like cyclic simple shear test, cyclic triaxial test, resonant column test, and also this calibration testing. So they attempted to get a proper calibration of measured CPT to adopt for these calcareous sands. So then, after having all these parameters, so they said on some state parameter, and all this data has been evaluated, analyzed, they arrived the revised CPT cone resistance from the measured values. That is, of course, less than what was measured at the site. So that is what my recommendation here is, that the existing framework, of course, cannot be used. But if you ask me directly, of course, for a preliminary screening, that can be used. But if you have any critical, very mega projects, I would recommend to undertake a project-specific assessment, like very advanced laboratory testing to figure out what is the gap between the existing framework and the site-specific application. That will definitely give a better understanding. But to my knowledge, just we can advise, to my knowledge, there is no much research, literature is available as of now, wherein we can directly use that framework. Currently, it is not there. So definitely, it is having a distinct parameters, distinct characteristics. I have even seen that the resonant column data, the test data, wherein that shear modulus degradation is very high for the calcareous sands compared to silica sands. So definitely it is giving an indication that the initial resistance very much, but as the number of cycles increases, it degrades and it does not offer the resistance what we are talking about. So my recommendation is we should definitely, I don't know, it may not be applicable for all the projects. If it is a mega project, very critical, especially the artificial islands, it matters a lot. I would prefer, I would recommend otherwise, to consider very specific, advanced laboratory testing. So because we have done, we have taken the sample, sent to Singapore to do some of this testing. I don't know whether we have those testing.
We have it now here.
Yeah, I'm talking about 2013 or 13 or 14.
Okay.
We have taken some samples, sent back to the Singapore to do some stuff. So that is what my just takeaway here. Thank you very much.
Thank you very much for your comment. So certainly with calcareous sand, it's important to kind of look at it, and I agree with you, especially with big project, we need to look at things, site-specific, and don't take one answer or one solution as an umbrella for everything. One of the main characteristics, or we always talk about with calcareous sand, is its crushability, and how that crushability can impact the dynamic and cyclic behavior. Dr. Can you comment on that?
Well, the crushability is one factor which differentiates between silica sand and the calcareous sand. It's one factor when you do the testing before any compaction in the natural state, it gives you a different picture. But every cycle of compaction, whether it is vibratory or whether it is dynamic compaction, it gives a different low values because the particle tends to crush, and the crush will increase the fines in the soil, which tend to reduce the permeability, increase the settlement all goes. So that influences the all behavior of the soil. With every cycle of the loading, with every compaction, with every vibration, it will increase its, decrease its values, I can say. And for the seismic value, if you talk about seismic value, when the what relative density are safer for the silica sand, because of these characteristics, maybe not safer for the calcareous sand. Because of its crushability and less permeability, the soil got quickly high pore water pressure, which leads to the liquefaction procedure more quickly in the state of the liquefaction. So this is one thing that I look into, and the proper factors to be applied to get a realistic picture in the calcareous sand rather than the silica sand. So we have to be very careful to take the realistic parameter for designing in the calcareous sand than compared to the silica sand.
Thank you very much. Any comments? All right. So we'll get to our next question. It's going back to Dr. Connie. Given the unique characteristics you mentioned, I think you hint to it a little bit. So what kind of testing or studies would you recommend to do to kind of identify the proper parameters for design for this kind of conditions?
Yeah, thank you. So almost all the questions are somehow interlinked because the subject is very common, and all the questions have similar stuff. So the questions what I have just explained before, to identify the mechanical behavior of this particular nature of soil that we are talking about. Definitely, as I told before, I recommend to do this cyclic triaxial test, and also the cyclic simple direct shear test. Now, regarding the crushability, because I was saying that we have sent samples to Singapore, we have done the sieve analysis before and after testing. Then it has given clear indication that there is a crushing factor involved potentially. So of course, I cannot say how much crushing has happened. Again, that depends again the angularity and the carbonate content and all this stuff. But I cannot say that, but there is a considerable amount of crushing that has taken place. So, of course, now he's saying that we have the capability or facility here now in UAE. Definitely, I would prefer to do even the resonant column test, which will give us the actual behavior of that small strain modulus variation with the different cycles. So that will really give a better idea to characterize the soil, and accordingly we can proceed. What are the measures to be taken in the design, so that our design will be more safe and perfect. That much I can say. Thank you very much.
Hamid, you want to add any comments? All right. So, with this uncertainty and the gaps which we have been talking about, looking ahead, what are the most critical knowledge gaps you think exist currently, and how the collaboration between industry, academia, as well as regulators can help address these gaps? And Dr. Hamid, I would like you to comment on that, and then the rest I'm sure would be interested in commenting on this as well.
In last 20 minutes, we all discussed the unique characteristic of carbonate sand and how it is different to silica sand. Dr. Kunni mentioned some tests like cyclic triaxial and cyclic direct simple shear, resonant column. These are very good tools to help to understand the behavior of this material, and we definitely need that. There is another practical step is at the end we do in the field our CPT. So in the lab we have done with the specific relative density, we prepared the sample, at the specific confinement we have done the test. Now we want to correlate this to our data from the field. I want to address from two approaches. One is in the field also we can capture VS, and in the lab also we can capture VS. This is one approach that is very useful. The other thing is from CPTs in the field, how to get to the lab and how to combine them. Look, at the end of the day, the simplest things we want is CRR as a function of QC. That's the answer we want. Now in that, we want the fine content to be included, everything, yes, but that is what our ultimate goal. So how to make this connection? We have calibration chamber test, or better than that now, we have centrifuge in NYU. So what we can do with these things, we can try to see what CPT profile we get for a given fine content, given confinement. And with few tests, let's say 5, 10 tests, we make this correlation between relative density and fine content and the CPTs in the field. And then we fill the gap. And with this lab testing, we can combine and come up with the solution specific to our site, or generically about the whole project. Like they are very similar. They are very similar in terms of having shell material. Okay, we can maybe later on see what the difference once we build up more information. But there are three main group of players here. One is industry as consultant, contractor, and the owner. One is academia. One is the regulator. These three needs to work hand in hand to get to this point. And honestly, we have been a little bit lazy. We should have done it much earlier. We have the data from the field. We have the facility now in UAE with centrifuge testing. Now regulator can push for it I know the regulator needs to see from academia some initial result, and once we develop that initial result, By the way, Fugro and NYU has already started working on a project on this to show to the regulator this is the difference. And now we are all focused on liquefaction mainly, but how about the cyclic behavior for a piles, especially in offshore industry? It is very important. That is not something that work in your favor. This compression and crushability makes you lose the strength. So all these fields needs to be captured, and these are the gaps we have here. And I think with these three parties working together, we have a very good chance. Like in a country that we are in the region, but mainly UAE, we say we are pioneer in largest project in everything. And reclamation is a big thing here. We have so many reclamation projects. We should be one of the first guys in the world that bring it to our regulation even properly with some data from the academia. I think we have the chance. We have a lot of database. We have the tools and facilities. It's just a little bit of investment required from different parties to get it rolling.
Thank you, Hamid. Thank you very much. So, Khalid, you want to comment? I also reserve to comment. I couldn't say it better than you. Thank you very much for your comment.
I just want to recall the days of the Palm Jumeirah when it first came into existence in 2003, I think so. At that time, there was no concept of this silica, calcareous and all that. All knowledge and everything was related to the silica sand. But when the post-testing was done for after vibro compaction for the Palm Jumeirah, it gives very surprising results. At that time, a lot of the consultant and the government itself sit together, they find out what's the difference, because the post-compaction results were not as per conceived that it should be. So at that time, all this is a shell correction factor and all that will come into that being. So it is that old. But since that time, nothing has been done in that factor. So now it's a time that we can just look into and give more input into that, get more realistic values factor, because 1.3 still has a conservative shell correction factor and all that. So it's academia and all that, we sit together to find out more realistic value, to find a better design and all that into it.
Sorry, maybe even change the formulation, not only a shell correction factor for say, you can have something better.
Any comments?
The same, what you said is like that. That is what I think the move should be like that.
Let me just add one comment. I think I agree. This is a time now there is a lot of resources. What I would like also to add for us as academia, we look at what you have as industry in terms of data in the field. This is a wealth of knowledge. We'd love to get access for this because you have one project. I know you have multiple projects, but you're looking at your project, you're focusing on it. It's the same with every company. When we get this data, we look at the full picture. We can come up with a framework which is not addressing only one unique site, but can be a solution which can be adopted in the region. So working between academia and industry, using facilities we have, as well as getting access to what exists, I think would be the key to kind of progress this and have some results. Because the data you're looking at from silica sand were from field data and a lot of experiments as well. So hopefully with this understanding, industry will open up a little bit and share some of existing resources in terms of data will help us address this. So before I think we have a couple of minutes for questions from audience or?
Yes, we have. I found very interesting all of it discussed.
Okay.
Very organized panel discussion. I have to participate all of you.
Thank you.
Please feel free to ask a couple of questions. Please.
Thank you. I want just to ask a question and maybe an observation. Maybe to Dr. Koni and Professor Tariq can add, and the gentleman as well. You recommended the cyclic test for the carbonated sand, such as the cyclic direct shear, triaxial, and resonant column, and centrifuge as well. But maybe I would cite back what Hamid said about the reclaimed sand is heterogeneous in nature. So how much or how many tests are enough to capture the whole variability of the reclamation? This is one part. The second part, we eventually rely on the CBT, pre-CBT and post-CBT. I was waiting for Gro to say that. Why we don't use the seismic CBT? We can get the full CBT profile with the shear wave velocity as well. We can have a direct correlations between the two. And unfortunately, the shortcoming now, all the correlations we are using is for silica sand from the CPT and the relative density. There is no local correlations available for carbonation or calcareous sand. And maybe this is, Professor Tariq, the role of academia to establish a local correlations and equations.
Yeah. So I understand your question. Now let us just think about, you are talking about the heterogeneity versus the number of tests that we do. So when I say heterogeneity, we have to see under what conditions, on what parameters we are talking about. So when you say heterogeneity, probably the material properties or the fine content, right? And heterogeneity may be in the vertical direction or in the spatial direction. So when, because we are dredging a material from the sea source and pumping and forming island, in this process, definitely we cannot have very much homogeneous material in terms of fine content, which play a critical role. So when there is a possibility of heterogeneity in terms of fine content, and when I say fine content, definitely there is a carbonate factor will be there. So across the island, if I have, say, for example, 500 meter by 500 meters, about 20 meter deep, if you talk about the complete, this mass, I'm not sure whether we have very much uniform material. That is nearly impossible, possibly. So now if you talk about target the testing for every variation in terms of depth and all, I don't think it is possible. So that is the reason we are targeting to take some sample which is well representing for the overall mass and do test. It will give definitely a better picture or better understanding, better than nothing. So that is where the start. Now if I ask you to do, say the test is very expensive, by the way. First of all, there is no head start to do testing in the first place. Now we are talking about the quantity. It is too far. Now there should be a movement, especially of the critical mega projects. The importance has to be noticed, importance has to be given, and there is some start. Once the database will develop, then when we have a data, then we will have a more scope to have more discussions, more analysis, more correlations. It is not the one-day job, by the way. So there should be some start. Then that is how we create the database. Then Dr. Ahmed said, we have, and also the Professor Kal said, so we have a lot of data that has to be gained, the access should be given, and start working on that. Create correlations, database, some indication will be there when we have a data. So that is where I think we have to start. So thank you very much for your question.
A quick comment. I think you're correct, right. I think joining between academia and industry is the key to get access to this, to be able to develop kind of guidelines and parameters linked to the region, and using some of the new tools in the region in terms of testing to complement that as well. Right? One
Thank
last
you.
question.
Good morning, gentlemen. It's a very interesting and fruitful discussion. Myself, Vijay, Technical Manager, Ground Improvement from Behaviour. I have the same question Professor Ghanim already asked. Why are we not discussing about the seismic CPT? Is there any case study that you did seismic CPT and you you tested the shear wave velocity and correlated that from the field test and correlated the shear wave velocity to QC, CPT QC, and then compared that with the actual CPT QC and established initial correction factor? Is that a good approach? Is that a reasonable approach?
Look, using VS as general, not only CPT, using VS as general is a good approach. I think we kind of bypass the shell correction factor by going to that. I don't think it's necessarily correct though, because we still need to do some research on that. We have used CPTs, seismic CPTs. We have used VS as well for our calculation. But honestly, we have very few data points like this. We don't have a lot of data as CPT. It's not as quick as CPT, by the way. You need to stop, bank, and then measure, then you have a change in your QC profile, then you need to take care of that as well. So it's not super easy. I would prefer MSW, honestly. It's more continuous.
But you can make an attempt like you can frequency on a 100 by 100, you do one seismic CPT, and then you can compare, like not like very frequently on a 30 by 30.
Definitely a good tool. We need to build it up. So the quick answer is, yes, I do support the idea. We need to push for that. We need to push, okay, you are doing every 30 by 30 meter, one CPT. Every 200 by 200, one of them should be seismic CPT. And then we do calculation, we compare, all of them we can do, and then we build the knowledge.
I'm not against the centrifuge laboratory testing, but for me, more realistic is the field comparison.
Field is always the most realistic, and we refer to it all the time. Nobody will debate with
Look,
it, so.
no, I have a comment here. The formula you are using, even with VS, developed for silica sand. So centrifuge test, for example, what we did with Dr. Tarek, we gave the exact motion history, and they modeled it in centrifuge because they have shaking table. And you can see how the pore pressure is generated, what is RU, all those things you can see from the test. It is very powerful tool. Of course, it is expensive. You cannot run in every single small project. This is good for developing the framework. Then we need to combine with other things, with VS. I'm a big supporter of VS, but it is a part of the whole process as well.
So for the sake of time, we have to conclude now, and please join me in thanking our panel members for their great input. Thank you.
Thank you very much.